Hey everyone, welcome back. Today we're going to be doing a deep dive into a paper that's really pushing the boundaries of AI research. Human-centric foundation models. It's a fascinating look at how AI is evolving to understand, generate, and even interact with us humans on a whole new level.
Yeah, it's really remarkable how fast this field is emerging. We're moving beyond those task-specific models and into this era of powerful generalist models that can tackle all sorts of human-centric tasks.
Exactly, and the paper we're looking at today lays out this whole new frontier. It's called Human-centric Foundation Models, Perception Generation, and Agentic Modeling by Chathuman and others. And they break down HCFMs into 4 exciting categories, from basic perception to AI that can actually interact in physical environments.
Yeah, what I find really intriguing is how this paper connects to the rise of large language models, LLMs. We're seeing a real convergence of language understanding and human-centric AI, which opens up a whole bunch of possibilities.
Absolutely. So for those of you tuning in who want the quick version, here's the gist. HCFMs are all about understanding, generating, and even mimicking human behavior.
Right. These models are trained on huge data sets of human data, allowing them to perceive and analyze everything from our physical appearance and movements to our emotions and social cues.
Think of it this way. These HCFMs can analyze images and videos to figure out things like a person's pose, their emotions, even their identity. They can basically see us, understand us, on a deeper level than ever before.
And they don't just stop there. HCFMs can also generate incredibly realistic digital humans, avatars, and even human-like movements. This is what we call human-centric AIGC, AI-generated content.
So imagine creating lifelike characters for video games, realistic animations for movies, or even virtual assistants that look and move just like real people. That's the power of these AIGC models.
Now, if you take that a step further and combine perception and generation, we get into this realm of unified models, AI that can both understand and create human-centric content.
This is where it starts to feel truly futuristic. These unified models can take input from multiple sources like text, images, and videos, and then use that information to generate new content, make predictions about human behavior, or even control robots in real-world environments.
And that brings us to the final category, Agentic Models. This is like the cutting edge of HCFM research, where AI is being developed to not only understand and generate human behavior, but to actually interact with humans in the physical world.
It's mind-blowing stuff. These agentic models are paving the way for humanoid robots that can follow your instructions, learn from their environment, and even anticipate your needs.
Of course, with this level of sophistication comes a whole set of ethical considerations. As we develop these increasingly human-like AI systems, we need to be very mindful of their potential impact on society.
Absolutely. We need to ensure that these technologies are developed and deployed responsibly and ethically.
So there you have it, the 4 key categories of human-centric foundation models. It's a rapidly evolving field that's full of potential, but it's also one that requires careful consideration and a commitment to ethical development.
Okay, now that we've got the big picture, let's unpack these categories one by one. Starting with human-centric perception foundation models. These models are all about teaching AI to see and understand humans in all our complexity.
Right, and it all starts with data. These models are trained on massive data sets of human data, allowing them to learn the intricate patterns of human appearance, movement, and behavior.
It's like giving AI a crash course in human anatomy and psychology. And they use this knowledge to perform some pretty impressive tasks.
For example, they can do things like person re-identification, which means matching individuals across different camera views or images. This is incredibly useful for security applications. But it also raises privacy concerns that we need to address.
Right, and they can do human parsing, which is like segmenting a person into different body parts, head, torso, limbs, to understand their posture and movements.
Yeah, this is essential for applications like motion capture for animation and video games, as well as for developing robots that can interact with humans in a more natural way.
And don't forget pose estimation, where they can accurately determine a person's posture and limb positions, even from a single image.
Oh, this has applications in everything from sports analysis to healthcare, where it can be used to track patient movement and rehabilitation progress. They can even create a 3D model of a person from an image or video.
Whoa, that's some next level stuff. And then there's skeleton-based action recognition, where AI can identify actions just by analyzing the movement of a person's skeleton.
This is opening up exciting possibilities in fields like sports training, where AI can analyze an athlete's movements and provide feedback on their technique. And in security, it can be used to detect suspicious activity or even predict potential threats.
So these perception models are really laying the foundation for a whole new era of human-AI interaction. But how exactly do they learn to do all of this?
Well, there are two main learning frameworks that are being used to develop these perception models: unsupervised learning and multitask supervised learning.
Let's start with unsupervised learning. This is where the models learn from data without explicit labels, meaning they have to figure things out on their own, just like humans do when we're learning something new.
Exactly. And they do this by relying on the inherent structure of the human body to extract features and patterns.
So they're basically learning by observation and experimentation.
That's a good way to put it. For example, there's a model called Solider that uses an additional semantic classification loss to understand the meaning behind the visual data. It's like the model is not only learning to recognize objects, but also to understand their purpose and how they relate to each other.
That's fascinating. And then there's Lifted CL, which uses an adversarial loss to guide 3D skeleton estimations, making sure the AI understands 3D human structure.
It's basically a way of training the model to be more accurate and robust. By pitting it against another model that's trying to fool it, this adversarial process forces the model to learn more effectively and to generalize its knowledge to new situations.
So it's like a constant game of one-upmanship, pushing the AI to improve its understanding of human form and movement.
Exactly. And then we have multitask supervised learning, which is a bit more structured.
Right. In this framework, the models are trained on data sets with labeled data, which means they have more guidance in learning specific tasks.
And the beauty of this approach is that it enables the models to learn from multiple tasks at once. So instead of training a separate model for each task, you can train a single model that can perform a variety of tasks related to human perception.
That's incredibly efficient. Can you give us some examples of models that use this approach?
Of course. One example is Path, which employs task-specific projectors and hierarchical weight sharing to learn general human-centric representations. It's like the model is developing a universal understanding of human form and movement that can then be applied to different tasks.
That's a really clever approach. And then there's UniHCP, which uses a task-guided interpreter to manage dynamic queries and unify 5 different human-centric tasks in a single model.
Yeah, UniHCP is a great example of how multitask supervised learning can be used to create these incredibly versatile and powerful perception models. It's like having a single AI system that can see, understand, and analyze human behavior in all its nuances.
It's amazing how much progress is being made in this field. These perception models are truly groundbreaking, and they're just the first step in the evolution of human-centric foundation models.
That's right. These models are the foundation upon which we can build even more complex and sophisticated AI systems that can not only perceive and understand humans, but also generate human-like content and even interact with us in the real world.
Now that's what I call exciting. So let's move on to the next category, Human-centric AIGC Foundation Models. This is where things start to get really interesting, because we're talking about AI that can actually create things, not just perceive them.
It's the realm of digital creativity powered by AI. And in the context of humans, this means creating hyper-realistic digital humans, characters, and even entire virtual worlds that are almost indistinguishable from reality.
So we talk about those incredibly lifelike video game characters, those seamless special effects in movies, and even those virtual influencers that are popping up all over social media.
Exactly. And it all starts with the ability to generate high-resolution, photorealistic images of humans. This is where models like StyleGAN Human come into play. They use a technique called manipulating style vectors, which allows for incredible control over facial features, expressions, and even the overall style of the generated image.
Style vectors, huh? That sounds pretty technical. Can you break that down for us a bit?
Sure. Think of it like this. Every image has certain underlying features that define its style, like the lighting, the color palette, the texture, and so on. Style vectors are basically a way of representing these features mathematically, and by manipulating these vectors, you can control the overall style of the generated image.
So it's like having a set of sliders that you can adjust to create different looks and feels for the image.
Exactly. And StyleGAN Human is particularly good at generating images of human faces because it's been trained on a massive data set of human faces, allowing it to learn the subtle variations in facial features, skin tones, hairstyles, and so on.
That's incredible. So not only can these models generate realistic human images, but they can also control the specific details of those images with incredible precision.
Right. And then there's Portrait GAN, which uses a neural renderer to ensure 3D consistency in the generated images. This means that you can generate images of the same person from different angles, and they'll still look like the same person.
That's really important for creating believable characters for animation and video games. You don't want the character's appearance to change drastically every time the camera angle shifts.
Exactly. And it also allows for control over things like facial expressions, and even subtle movements like blinking and breathing.
It's amazing how much detail these models can capture. And it's not just about static images either. These AIGC models are also being used to generate incredibly realistic animations and videos of humans in motion.
That's right, and there are two main approaches being used to achieve this: unsupervised learning and multimodal supervised learning. On the unsupervised side, GANs, or generative adversarial networks, are playing a key role.
Can you refresh our memory on how GANs work?
Of course. A GAN consists of two neural networks that are pitted against each other, a generator network that creates images, and a discriminator network that tries to distinguish between real and fake images. As the generator gets better at creating realistic images, the discriminator gets better at spotting fakes. This adversarial process pushes both networks to improve, resulting in incredibly realistic generated images.
It's like a constant game of cat and mouse, pushing the AI to its limits. So how are GANs being used to generate realistic human animations?
Well, one example is a model called Human-SD, which uses a skeleton-guided diffusion model to generate high-quality images of humans in various poses and actions.
Wait, skeleton-guided diffusion model, that's a mouthful. Can you explain that in simpler terms?
Sure. Imagine you have a stick figure representing the skeleton of a human. This model can take that stick figure and use it as a guide to generate a realistic image of a person in that specific pose. And by varying the pose of the stick figure, you can create a sequence of images that form an animation.
So it's like the stick figure is a blueprint for the AI to create a realistic human image around. That's pretty cool.
It is, and the diffusion part of the model refers to a technique that's becoming increasingly popular for generating high-quality images. It basically involves starting with a random noise image and then gradually refining it until it becomes a realistic image.
And what about multimodal supervised learning? How is that being used to generate human animations?
Well, one really impressive example is Human 4DT, which is a 4D diffusion transformer model that can generate realistic human videos from just a single image.
Wait, from a single image, how is that even possible?
It's pretty mind-blowing, right? This model uses a technique called 4D representation, which means that it's not only considering the spatial dimensions of the image, height, width, but also the temporal dimension.
So it's like the model is able to extrapolate the movement of the person in the image over time, creating an entire video sequence from that single frame.
Exactly, and it does this by leveraging a massive data set of videos, allowing it to learn the complex patterns of human movement and apply that knowledge to the single image input.
That's some serious AI magic. It's clear that these AIGC models are revolutionizing the way we create and consume digital content. But it's not just about entertainment, right? These technologies have far-reaching implications for a wide range of industries.
Absolutely. Imagine the possibilities in healthcare, where these models could be used to create personalized simulations for surgical training, or to develop virtual therapists that can interact with patients in a more natural and engaging way.
And in education, they can be used to create immersive learning experiences that bring history and science to life in a way that textbooks never could.
It's really exciting to think about all the ways these technologies could be used to improve our lives. But of course, we also need to be mindful of the potential downsides.
Right, like the possibility of deepfakes being used to spread misinformation or to create harmful content.
Exactly. It's essential that we develop these technologies responsibly and ethically, and that we put safeguards in place to prevent their misuse.
Okay, I think we've covered a lot of ground in this first part of our deep dive. We've explored the fascinating world of human-centric foundation models, from perception models that can see and understand us, to AIGC models that can create incredibly realistic digital humans and animations.
And we've only just scratched the surface. There's so much more to explore, especially when it comes to the unified and agentic models that are pushing the boundaries of AI even further.
But we'll save that for the next part of our deep dive, so stay tuned and we'll be back soon to delve even deeper into the future of human-centric AI.
Welcome back, everyone. I'm excited to continue our exploration of human-centric foundation models.
Me too. Last time we really delved into the amazing capabilities of HCFMs for both perceiving and generating human-like content, but those were really just the building block.
Precisely. Now we're going to venture into the territory where things start to feel truly revolutionary. Human-centric unified perception and generation foundation models.
This is where AI goes beyond simply understanding or creating and instead does both seamlessly. It's like teaching AI to think and communicate more like us.
And as we touched on earlier, the real game changer here is the integration of LLMs, large language models, into the mix.
It's fascinating how language is becoming this bridge between different modalities like vision and action. The paper highlights two main paradigms for achieving this unification: vocabulary fixed and vocabulary extended models.
Let's start with vocabulary fixed models, where the goal is to translate human-centric data into the language model's existing vocabulary. It's like we're creating a Rosetta Stone for AI to decipher human behavior.
So instead of teaching the AI an entirely new language, we're showing it how to understand human actions and expressions in terms it already knows.
Exactly. And one of the most exciting examples of this approach is Kamo, which uses LLMs to generate textual descriptions of human poses, and then uses those descriptions to generate the corresponding motions.
So it's like the AI is learning to understand the relationship between what we say and how we move. Could you give us an example?
Imagine you give the model a text description, like the person raises their right hand and waves. Kamo would then use its knowledge of language and human movement to generate a sequence of motions that match that description.
That's pretty amazing. It's like the AI is learning to speak body language through text. The paper also mentioned Chathuman, which seems to take a more general-purpose approach.
Chathuman is a really intriguing example of a multimodal large language model, or MLM, which means it can process and understand information from multiple sources, including text, images, and even audio.
So it's not just about movement, but also about understanding context and meaning from different types of data.
Absolutely. Chathuman leverages a suite of 22 different human-centric tools to reason about and complete tasks related to humans. It's like an AI Swiss Army knife for understanding and interacting with us.
Okay, now let's move on to vocabulary extended models. These seem even more ambitious because you're actually expanding the language model's vocabulary to include human-centric data directly.
That's right. It's like we're teaching the AI a whole new dialect that incorporates concepts like pose parameters, motion sequences, or even emotions.
So instead of translating human behavior into existing language terms, we're giving the AI new terms specifically for understanding human actions and expressions.
Precisely. And this allows for a much richer and more nuanced representation of human behavior. One great example is Motion GPT, which treats human motion as a language itself.
It's like the AI is learning to read our body language as fluently as it reads text.
Exactly. And then there's L&M, which takes this a step further by unifying verbal and nonverbal language. It can understand and generate human motion based on text, speech, motion data, or any combination of those.
Wow, that's incredible. So it's not just about understanding one type of communication, but about integrating them all into a single, cohesive understanding of human expression.
It's truly remarkable how these unified models are blurring the lines between different forms of communication and paving the way for a more natural and intuitive human-AI interaction.
But all of this leads us to the question that's probably on everyone's mind. What's the point of teaching AI to understand and generate human behavior in such detail? Where is this all heading?
That's a great question, and it brings us to the most exciting and perhaps even unsettling category of HCFMs, Agentic Models. These are the models that take all this knowledge of human behavior and use it to create AI that can act and interact in the real world.
Now we're talking. This is the stuff of science fiction movies becoming reality. We're talking about robots that can not only follow our instructions, but also learn from their environment, anticipate our needs, and maybe even have their own goals and motivations.
Hold on, let's not get ahead of ourselves. While agentic models are rapidly advancing, we're still a long way from truly autonomic AI with its own agenda. But the progress being made is truly remarkable, and the potential applications are vast.
The paper focused specifically on the role of these models in robotics, particularly humanoid robots.
And for good reason. Humanoid robots are the embodiment of our desire to create machines in our own image. Machines that can not only perform tasks, but also interact with us in a way that feels natural and intuitive.
But building a robot that can move and act like a human is only half the battle. We also need to give it the intelligence to understand and respond to the world around it.
And that's where human-centric agentic foundation models come in. They provide the cognitive framework for robots to perceive the world, understand human behavior, and make decisions about how to act.
So it's like we're giving these robots a brain that's wired for human interaction.
Exactly. And there are two main approaches being explored for developing these agentic models: vision language-based models and vision language action-based models.
Let's start with vision language-based models. From what I understand, these models combine pre-trained vision and language models with control policies to allow robots to both understand and respond to commands.
That's a great summary. Essentially, these models give robots the ability to see the world, understand language, and then translate those inputs into actions.
So if I told a robot with this type of model to bring me a glass of water, it would actually understand what I'm asking and be able to carry out that task.
Precisely. And Human-VLA is a great example of this approach. It uses a vision language model, or VLM, to interpret natural language commands and then translates those commands into actions that the robot can perform.
That's really impressive. It's like having a robot butler that can understand your every request. But what about those vision language action-based models? How are those different?
These models take a more integrated approach, where language isn't just a separate input, but is woven into the very fabric of the robot's understanding of action. They treat robot observations and actions as tokens within a language model.
Tokens in a language model. Can you elaborate on that?
Think of it this way. Language models are trained to predict the next word in a sequence. In these vision language action models, the words are actually the robot's observations and actions.
So instead of predicting the next word in the sentence, the model is predicting the robot's next action based on its current observations and previous actions.
Exactly. This allows for a more holistic and fluid approach to action generation, where language isn't just an afterthought, but is deeply intertwined with the robot's ability to perceive and act in the world.
That's a really clever approach. Are there any examples of this type of model being developed?
Yes, a very exciting example is Nvidia's Project GR00T. It's a massive undertaking aiming to create a foundation model that can control humanoid robots in complex tasks, using data from both the real world and simulations.
Project GR00T. Oh, that sounds ambitious. What kind of tasks are they hoping these robots will be able to perform?
Well, the ultimate goal is to create robots that can perform a wide range of tasks, from simple household chores to more complex tasks in industrial settings, healthcare, and even space exploration.
Imagine a robot that can assist surgeons in the operating room, help care for elderly patients, or even build habitats on Mars.
The possibilities are truly mind-boggling, but of course, with this level of autonomy comes a whole set of ethical considerations.
That's right. As we develop these increasingly sophisticated AI agents, it's crucial that we do so responsibly and thoughtfully. We need to ensure that these robots are safe, reliable, and act in ways that align with human values.
Absolutely. We need to be mindful of the potential impact these technologies will have on society and work to mitigate any unintended consequences.
So we've covered a lot of ground in this second part of our deep dive. We've explored the fascinating world of human-centric unified perception and generation models, where language is becoming the bridge between human understanding and AI action. And we've delved into the realm of agentic models, where robots are being imbued with the intelligence to interact with the real world in increasingly human-like ways.
It's clear that the field of human-centric foundation models is rapidly evolving, and the next few years will undoubtedly bring about even more groundbreaking advancements.
But where do we go from here? What are the key challenges and opportunities that lie ahead in this field? That's what we'll explore in the final part of our deep dive. Welcome back to the final part of our deep dive into human-centric foundation models.
It's been quite a journey, exploring all these incredible advances.
It really has. We've seen how AI is evolving to perceive us, generate human-like content, and even act in the real world. It's amazing.
Yeah, but as with any powerful technology, there are always challenges and opportunities.
Exactly. So let's dive into some of the key areas that researchers are grappling with as they kind of push the boundaries of human-centric AI.
Sure. One of the biggest challenges is creating models that can truly generalize to new situations and environments.
Yeah, right now, most HCFMs are trained on very specific data sets, which means they can struggle when faced with something they haven't seen before.
They're great at following instructions and performing tasks within a defined set of parameters, but they don't have that same flexibility and adaptability of human intelligence.
So how do we bridge that gap? How do we create AI that can learn more efficiently, adapt to new information, and apply its knowledge to novel situations?
Well, that's the million-dollar question. One promising approach is to focus on developing models that can learn from fewer examples, what we call few-shot learning.
So instead of needing millions of data points to learn a new task, these models could learn from just a handful of examples, much like humans can.
Exactly. Another area of focus is on developing models that can learn continuously throughout their lifespan.
So instead of being trained once on a fixed data set, these models would constantly be learning and adapting to new information.
Right. This would allow them to keep up with the ever-changing world and to become more versatile and robust over time.
Makes sense. Another challenge we touched on earlier is creating AI that can really understand and respond to human emotions and social cues.
Yeah, it's one thing to recognize a smile or a frown, but it's a whole other thing to grasp the complex social dynamics that underlie human interaction.
We need AI that can understand not just what we say, but how we say it, and the subtle nonverbal cues that convey so much meaning.
And this requires going beyond simply recognizing facial expressions or analyzing tone of voice. It's much deeper than that.
We need AI that can infer our intentions, understand our motivations, and even predict our future behavior based on our past interactions.
This is a tall order, but it's essential for creating AI that can truly collaborate with humans on a much deeper level.
For sure, and let's not forget the ethical considerations that come with developing increasingly sophisticated AI systems.
Absolutely. As we create AI that's more and more human-like in its capabilities, we need to be incredibly thoughtful about the potential consequences.
We need to ensure that these technologies are developed and deployed in a way that benefits all of humanity, not just a select few.
Right. This means addressing issues like bias, fairness, transparency, and accountability.
We need to make sure that these AI systems are not perpetuating existing societal biases, and that they're being used for good, not for harm.
Yeah, it's a complex and multifaceted challenge, but it's one that we must confront head-on if we want to create a future where humans and AI can coexist and thrive together.
Okay, so we've talked about the challenges, but what about the opportunities? Where do you see the most exciting potential for HCFMs in the future?
Oh, the possibilities are really endless. I'm particularly excited about the potential for HCFMs to revolutionize healthcare.
Yeah, imagine AI-powered diagnostic tools that can detect diseases earlier and more accurately than ever before.
Or virtual therapists that can provide personalized support and guidance to patients struggling with mental health issues.
And robots that can assist surgeons with complex procedures, making surgery safer and less invasive.
Absolutely. HCFMs could also transform education, creating these personalized learning experiences that cater to each student's individual needs and learning styles.
Imagine AI tutors that can provide real-time feedback and guidance, helping students to master new concepts and skills more effectively.
And AI-powered educational games that make learning fun and engaging for students of all ages.
And then there's the potential for HCFMs to revolutionize the way we work.
Yeah, imagine AI assistants that can handle those mundane tasks, freeing up human workers to focus on more creative and strategic work.
Or AI-powered collaboration tools that can help teams to communicate and work together more effectively, regardless of location.
And AI-driven systems that can analyze vast amounts of data to identify trends and insights, helping businesses to make better decisions and to stay ahead of the competition.
It's clear that the future of HCFMs is bright, full of potential and possibility.
But it's up to us to ensure that this technology is developed and used in a way that benefits all of humanity.
That's right. We need to approach this new era of human-centric AI with a sense of responsibility, ethical awareness, and a commitment to creating a better future for everyone.
That's a great point to end on. It's been a pleasure delving into this topic.
Me too. It's been an incredible journey. And I can't wait to see what the future holds for Human-centric Foundation Models.
To our listeners, thanks for joining us on this deep dive. We hope you found it informative and thought-provoking.
And remember, the future of AI is not predetermined. It's up to us to shape it in a way that aligns with our values and aspirations.
So stay curious, stay engaged, and let's work together to create a future where humans and AI can flourish together.